In this video, we're going to be discussing polyatomic ions, which are a special type of ion that can be a little bit larger than the regular monatomic ones we've been working with to this point. As has been tradition for this chapter, you will need something to write with, something to write on. Your periodic table and chart of charges would be lovely, so please make sure you have them. And if you are ready, let's start. Okay, so we should probably go over what a polyatomic ion is, right? All it is, it's just a group of elements that act like a single ion. So, for example, if I were to look at carbonate, right, carbonate is a carbon atom bonded to 3 oxygen atoms, and that group overall, all 4 of these elements combined, have a -2 charge. All right, so that's a polyatomic ion. Your chart of charges has a bunch of them. Right, so one thing to keep in mind is that you can form multiple different polyatomic ions from the same 2 elements, right? Usually what you'll see is you'll see 8, the prefix for one of them, the one that has more oxygen, and 8, the prefix for another that has less oxygen, right? So for example, if I take sulfur and oxygen, I can do SO4 with 2 minus. This is called sulfate. Or I could take SO3 2 minus. Notice the only difference is it has 1 less oxygen. So instead of sulfate, this is sulfite. Right? And keep in mind, if I just had sulfur with a 2 minus charge from our previous binary, this is sulfide. So notice 8, ite, and ide. They are all spelled very similarly. This is going to be the tricky part with writing names because you will mess these up when you look at them on a table or on a chart. Please be very careful because if you say sulfide when you mean to say sulfate, I have no choice but to mark it wrong. All right, so please be very, very, very careful with that. And all of the ones that we are going to use this year are on your chart of charges. So the backside of your periodic table will have them. The negative ions are in the first column. The positive ions are in the second column. Now, I do need you to make one change on your chart of charges to one of the positive ions. And this is just going to be for my purpose. This isn't how it works in real life, but I want to make it a little bit easier for you. And that is that if you have mercury 1, we're just going to call it Hg+. Right, on your chart of charges, it will say Hg2 with a +2, right, because mercury 1 is technically a diatomic ion. That's really, really, really tricky to work with. So I'm going to change it and have you guys put down this instead, right? Again, not technically what it is, but it will work easier for us at this stage in your chemistry development. So just like binary compounds, we're still going to drop and swap these. There's just going to be one small little change. And that small little change is that if you have to put a number next to a polyatomic group, that group goes in parentheses and the charge goes outside. All right, so for example, let's say that I had, well, actually I have an example coming up in a second, so hold off from that. One other thing to keep in mind when you have these is that the formula for the group cannot be changed under any circumstance, right? So if I had, for example, the oxalate ion, C2O4-2, I can't reduce the 2 and 4 down to smaller ratios. They have to stay as they are always. You use parentheses, you do not affect them at all. So here's a quick example, magnesium chlorate, right? So this is how the drop and swap will work. Magnesium is still +2. Chlorate, if we look it up on our chart of charges, is ClO3 with a -1 charge. Right, so far, nothing too difficult. We're going to do our drop and swap. Right, so we've done our first step. Second step, get rid of the charges, or the signs, I should say. So get rid of the plus, get rid of the minus. Now we're going to drop and swap. There's a 1 up here that we don't care about, right? Because we don't write 1s. But we're going to have to drop and swap this too. We do not make this O6 or O5 or Cl2O6 or anything like that. All we do is we do Mg, then ClO3. We put the ClO3 in parentheses with a 2 outside. Do not use parentheses unless you put a subscript next to the group. Right, so this is how we handle dropping charges next to a polyatomic ion. So let's try a few of these. All right, so oxalate again. So sodium oxalate. We'll try this one out. So I'll try this one. All right, so sodium oxalate. Sodium is Na+. Oxalate is C2O4 with a -2 charge. Our second step of the drop and swap is to take care of the charges, or the signs again. So we're going to get rid of the plus and the minus. Now we're going to drop and swap the 2, right? So the 2 is going to come down here, and we get Na2, C2O4. This is our final answer. We do not reduce the 2, 2, and 4. All right, even though it looks like we can because they're all divisible by 2, we don't touch them. The reason why? We cannot edit C2O4 at all. That is the ion. It has to stay that way. All right, so how about you guys try this one? This is going to be aluminum dichromate. You will find dichromate on your chart of charges. The left-hand column is in alphabetical order. So take a couple minutes, try this, and then get back to me when you think you have an answer. Okay, so aluminum dichromate. The symbol for aluminum is Al+3. Dichromate is Cr2O7 2-. Right? So now what we do our drop and swap. We get rid of the signs. So let's get rid of the plus, get rid of the minus. 3 and 2 cannot reduce down. So I'm going to drop the 2 down next to aluminum and the 3 next to my dichromate. I'm going to get Al2, Cr2O7, and because I'm dropping a 3 next to the group goes in parentheses with the 3 on the outside. So this is doing drop and swap with polyatomic ions. Works very similarly to what we've done before. All right, so I will see you guys in class.